Good morning. Hello and welcome everyone. In today's world where digital ecosystems are expanding faster than ever, security can no longer be a afterthought. It must be engineered, built in, not bolted on. I am thrilled to invite you to a comprehensive 12-part video series on security architecture and engineering, a foundational and advanced exploration that bridges theory, practice, and governance. Whether you are a student beginning your journey, or a cybersecurity practitioner refining your craft, or a compliance professional aligning systems to regulatory mandate, this series has been thoughtfully created for you. In phase 1, we set the groundwork with core concepts. We unpack security models like Bell-LaPadula, Biba, Clark Wilson. We understand system architecture and its principles, including the trusted computing base and the reference monitors. We'll explore preventive, detective, and corrective controls, evaluate systems through common criteria, TCSEC and ITSEC, and dwell into cryptographic design and secure system components like hardware, firmware, and softwares. That's phase 1. In phase 2, we move into deep technical exploration. Here, we explore security design principles like defense in depth, least privilege, and fail secure. You learn about enterprise architecture frameworks such as SABSA, TOGAF, and Zachman. We'll also cover secure coding, SDLC security integration, engineering focused vulnerability management, and dwell into architecture for embedded systems, IoT, mobile, cloud native platforms, and containerization. You will gain insights into hardware based securities like TPMs, HSMs, secure boots, and trust zones, as well as emerging domains like zero trust architecture, confidential computing, and the impact of AI ML on architecture. In phase 3, we'll turn the spotlight to real world relevance through threat modeling methodologies like STRIDE, DREAD, and PASTA. We will analyze actual breaches, what went wrong, and what could have gone right. These case studies will contrast vulnerable versus resilient architectures, giving you blueprints for building secure enterprise patterns while avoiding anti-patterns that exposes organizations to risks. Finally, in phase 4, we will converge technology with governance. We will explore how to map architectural design to standards like ISO 27001 Annex A, NIST SP 800-160, and others. We learn how to perform architecture level risk assessments and how to design systems that are not only secure but compliant with global regulations like GDPR, India's DPDP Act, HIPAA, and PCI DSS. Each episode is crafted with clarity and depth, backed by real world examples, theoretical models, and regulatory insights. My goal is to demystify complex security concepts, empower you to design defensible systems, and help you think like a security architect. So, if you are passionate about building systems that are secure by design, resilient by architecture, and governed by compliance, this series is for you. Please subscribe, follow along, and join me in this transformative journey into security, architecture, and engineering. Let's build a safer digital world, one secure design at a time. This is your host, Savit Vittal Salian. Namaskar. Security Architecture and Engineering, Part 7, Enterprise Security Architecture Framework. Enterprise Security Framework, Architecture Framework has 4 distinct spaces. Sherwood Applied Business Security Architecture, TOGAF with Security Architecture, Zachman Framework, Comparison and Practical Applications. Let's look at it one at a time. Enterprise Security Architecture Framework. It helps the organization design, build, and manage secure IT environments in a structured way. These frameworks align security goals with business objectives and ensures that security is integrated throughout the entire organization. The Sherwood Applied Business Security Architecture. It's a risk-driven security architecture framework that starts with business needs and links them to security requirement through a series of 6 layers, namely contextual, conceptual, logical, physical, component, and operational. SABSA is a security framework that starts with business requirement and not technology. That's the uniqueness of this. It ensures that security services support business goals and business risk. It is especially useful for aligning security with governance, risk management, and compliance needs. SABSA uses layers and models, whether it is contextual, conceptual, logical, physical, and component, to build security into the architecture from strategy to implementation. Let's look at how it works. Let's take a theoretical example. A retail e-commerce company, it's a large online retailer, wants to ensure secure customer transaction, protect inventory data, and meet the PCI DSS compliance requirement. They use SABSA. The architecture team works through the layers. When it comes to contextual layers, business drivers are identified. Example, protect customer trust, support 24/7 services, meet compliances. When it comes to conceptual layer, they define security objective, which is confidentiality of the cardholder data, integrity of order processing. When it comes to logical layer, they design access control, identity management, and secure transaction flow. When it comes to physical layer, they choose specific technology, example, web application firewall, secure API, role-based access. When it comes to component layers, they implement solutions to integrate with, like example, Okta for IAM, use TLS for secure transmission. When it comes for operational layer, they set up monitoring, incident response, and periodic control assessment. The result? Security is aligned with the business outcome, traceable from top level strategy down to the technical implementation. Now that's SABSA theoretical example. Real world example? Well, government identity program as an example. A national government rolls out a digital identity program for its citizens. To ensure security and privacy by design, the project team adapts SABSA. At the contextual level, the mission is to enable digital service while protecting the personal data. That's the contextual level. At the conceptual level, they define trust models, user roles, and risk tolerance. At a deeper level, this translates to using biometric authentications, PKIs for digital signatures, and smart card technologies. Thus, by using SABSA, the government ensures that each security control directly supports a business goal of being trustworthy and secure citizen services. TOGAF, the Open Group Architecture Framework. TOGAF is a comprehensive framework used for enterprise architecture. It includes a methodology called as architecture development method to guide the creation of business aligned end to end architecture, including security. TOGAF is a widely used enterprise architecture framework that includes a security architecture domain. The architecture development method is a core of TOGAF and helps design systems from a high level business view down to technical implementation. TOGAF provides a common language and process for architects, developers, and business leaders. TOGAF, the security in TOGAF is considered across all phases, ensuring risks are identified and controlled and controls are planned early. Let's take an example to understand this better. Considering a global manufacturing company. A global manufacturing firm wants to modernize its IT infrastructure and move to cloud while ensuring security is built in from the start. Using the TOGAF ADM, they follow these phases. First, the preliminary phase, wherein they define the architecture principle, which is example security by design. From a business architecture perspective, they map the business goals like securing supplier access and reliable production system. Then they move on to the information systems architecture where they define secure data flows and application interactions. When it comes to technical architecture, they design secure infrastructure using cloud, VPNs, and identity federations. From an opportunity and solution perspective, they select security tools such as endpoint protection, SIEM, etc. When it comes to migration planning, they develop a phased rollout while minimizing the risk. When it comes to implementation governance, they track the execution, ensure compliance with security policies. When it comes to architectural change management, they monitor and adapt the architecture as threats or business needs evolves. With TOGAF, the organization ensures that business, application, data, and technology architectures are developed together with security built into each layers. Real world example? Well, let's take a financial service organization. A multinational bank uses TOGAF to design its digital banking platform. Security is integrated into each ADM phases, which include business goals, includes secure online transaction and regulatory compliance. The data architecture phase incorporates data classification and encryption. The technology architecture phase includes deploying cloud firewall, zero trust networks, and secure APIs. The security architects work along the enterprise architect to define controls and KPIs aligned with business risk. The outcome? A secure by design banking platform with a clear traceability path from business needs to security controls. Zachman framework. Zachman framework is a structured way to organize and view an enterprise architecture using a matrix. It helps ensure that every aspect of system is considered from multiple viewpoints across both business and technology layers. For an example, it could be rows would be different stakeholders and columns fundamental question. When you say stakeholder, it could be planners, designers, developers, users. Fundamental question: what, how, when, where, who, when, why, etc. Though it is not a security specific, it can be adapted to support security architecture efforts by ensuring no blind spot exists in a design. Zachman is a classification scheme that organizes architectural artifacts like models, document, and process. It uses the six questions: what, how, where, who, when, and why, and six perspective from planner to functioning systems. Zachman is often used as a foundation upon which other security focused frameworks are mapped. While it is not security specific, it helps organizations systematically consider security at every level and viewpoint. Well, theoretical example, let's take insurance company. An insurance company is building a secure online claim processing platform. They use the Zachman framework to ensure complete architectural coverage. So from a planning view, we say what data needs to be protected, claims, IDs, etc. How will user interact, whether it's web or mobile? Where is the data stored? Who uses it? When are processes triggered? And why build this? That's a planner's view. From a designer's view, question would be, what are data entities? How does the process flow? Where are the servers? Who manages access? When is data archived? Why these controls? This should help you get a perspective on how Zachman framework works. By populating this matrix, the company ensures data privacy, regulatory alignment, and system accountability across all architectural layers are addressed. Real world example: US federal government IT planning. Some US federal agencies use Zachman framework to develop enterprise-wide IT blueprint, especially when coordinating across multiple departments, ensuring system integrates securely and also align with standards like NIST, RMF, and ISMA. By applying Zachman, they ensure each architectural viewpoint, whether it is business, system, network, users, governance, are addressed, minimizing any oversight in security and compliance. In comparison, SABS, TOGAF, and Zachman, SABS, it is best when you want security tied directly to business drivers. That's where SABS come into play. TOGAF, it's ideal for enterprise-wide architectural planning, which includes security. Zachman, it helps ensure no architectural aspect is or are overlooked. So organizations often use a combination of this framework to cover both business and technical needs. These framework helps ensure that security is not just an add-on, but an integral part of the entire business and IT strategy. I hope this helps you with the right context and a perspective on these aspects. With this, we come to the end of part 7. I hope this has helped you in some way. We will now move to part 8. We'll end this part 7. This is your host, Savit Vittal Salian. Appreciate the time that you have invested in this. See you in part 8. Namaskar.